So what do y'all see now? What are y'all seeing now?
I still just see you.
I saw the PowerPoint for a second, but it's back to you.
So what do y'all see?
I see the PowerPoint.
I still see the PowerPoint?
Yes.
Yes.
Okay. So I've done something, of course, again, and don't know what I did, so we'll go from here. So we went over this slide the other day. The triangular is similar. ABC is similar to DEF, and it's written as this, exclamation point. And then this little similar is not going to have the same symbol as congruent. Congruent has the symbol of the equal sign and the congruent thing. Y'all are looking at a slide with definition of similar triangles, correct?
Yes.
Okay. So what happens is the similar is a little bit different. So as you come down here, it's also noting how which angle is congruent to the other angle. So these two triangles are similar if and only if these angles are congruent with the other angle from the other triangle. And these sides are congruent. Now you see it's got a scale factor, and that's showing that so as it's looking here, it's got A, B, C, D, E, F, and you notice that it's written in the order that A is going to be similar to angle D. It's going to be congruent to angle D, and B is going to be congruent to angle E. And that shows that C then is going to be congruent to angle F. And then these sides are going to be in a scale proportion. They're not going to be the same length, of course, but so if this side was, if side AB was 2, that means that side DF may be 6. So if this was 2 and this was 6, then if this was 1, then DF would be 3, because I multiplied 2 times 3 to get to the 6. So 1 times 3 to get here. And I'm going to draw this out in just a few minutes, but I want you to get, because their drawings are so much better than mine. Now, this is something totally different, because now it's asking you, okay, if we've got something that is in similar to one another, so if we say that LTK, angle LTK, is similar to LNM, then we've got to show and fill in some blanks. So they flip these triangles, so we can't just say, okay, well, this one is similar to whatever one over here. This is the 90-degree angle. So the side opposite the 90-degree angle is right here. The side opposite this 90-degree angle is LN. So we can say that LT is congruent to ln because we've got a scale factor. Now, if we look at this line here, KL, it's 125 feet. Well, it's congruent to LM, which is 50 feet. And so they're asking us, if this line MN is 30 feet, then how do we find the KT line? And this is the same thing as we do proportions. By the vertical angle theorem, and this was in your homework, so if you got to it and you weren't really sure what it was, the vertical angle theorem, it says angle TKL is congruent to angle NLM. So that means that angle K is congruent to angle M. And by the angle property, we can say that side TK over NM is congruent to KL over ML. So I'm going to TK over NM is equal to KL over ML. And this actually means that they're proportionate to each other. So I wrote those sides down. So it says that TK is in proportion to NM, which is right here, the other triangle. So KL is in proportion to ML. Now you notice those are the ones that are congruent to each other, the sides. So when you put it on there, it's saying that if you fill in the blank, so the TK side had a length of X, the NM side had a length of 30 feet, and that equals to the KL side had 125 feet, and the ML side had a length of 50 feet. So all we do here is just do our proportion. So we're cross multiplying and then solving for X. So is everybody with me here?
Yes.
Yes.
Okay. So when they cross multiply and solve for X, then X is going to be 75 feet. Now, if you had looked at this and said, okay, I multiply 50 times 3 to get to 125, or how many times will 50 go into 125? And then you got to multiply that same thing. This is the most correct way of doing it, is setting it up as a proportion and then setting it and then solving for the X side. Now, this is the side property that we talked about. So if the sides that are similar are in proportion to the sides of another triangle, then we're saying that the two triangles are similar to each other. So that's the same thing as that, like I said, this may be a 2 and this is a 6. And so then this may be a 3 and this be a 9. So they're all in proportion to each other. So that means that both triangles are going to be similar to each other. This is taking into effect the side angle side property. If in two triangles the ratios of two pairs of corresponding sides are equal and the included angle are congruent, then the two triangles are similar. So in your homework, it's going to ask you, are triangles similar? And it's going to ask you why. So you've got the side, side, side. The first one was angle, angle similarity. The next one we did was side, side, side. And this one is going to be the side, angle, side similarity. So if we have a side, two sides, and the angle in between those two sides is similar, if they're the same, then we know that those two angles are going to be, two triangles are going to be similar to each other. Now, I'm actually going to not stop presenting, but I'm turning off the PowerPoint and turning off my calendar. Sorry, people, you're going to get sick. Motion sickness because I'm moving you. So this is in the book. And it's asking you, it's on page 654. And it's asking you, you've got a pair of triangles here, and you have a pair of triangles here, just A and B. So which pair of these triangles are similar, and why? So as you're looking through the book at similar triangles, we've got this one here that's called an angle, angle, angle. So you may want to write these down on your little notebook, angle, angle, angle. And then we have the ones that are side, side, side. And then we have a side, angle, side property. Okay, so as you're looking at these two, you've got to use one of these properties in order to determine which one of these. So I know that if this is 30, 60, this has to be 90. But do we have anything that's an angle, side, angle? Because that's all I'm given on this side. And I'm given an angle side, but I'm not given this angle. Does that make sense? So I'm given an angle, angle, side. I'm given an angle, side, angle. So none of my properties that I have fit these two triangles. So this is the one that's actually going to be the one that's the similar triangle. And I would, so I got 5, 6, I like all these political things that come through now because they always have abbreviations. So I've got a call coming in from. So if you look at this, and I didn't draw them to scale, I realize, this one's actually flipped from this one. So if we want to make sure that we've got the sides and make sure to see what it looks like, I can actually change this so now this is going to be 12, this will be 5, and this is going to be 10, and 10 is going to have, so you got Q here, S, and then R. So now we can look at the proportions of these two. Sorry, I keep moving it. We can look at the proportions of these two triangles and say that DF, which is 5, is proportionate to RS, which is 10, and that is going to equal, I can do either one of these. I can do RQ, which is, and DE, which is 6 over 12. And even though I'm not searching for an X, I can still multiply across and say that 5 times 12 is equal to 6 times 10, and 60 equals 60. So yes, these two are similar and congruent. So this is actually going to be a side, side, side property that we're using. So if you have to flip, and that's where on the homework, remember you can always go up to those dots in the upper right corner and click print, and it'll ask you, do you want to print this problem or the whole homework assignment? If you do the whole homework assignment, then it'll print them front and back, which is fine. If you want to just do one question at a time, or tell it not to print front and back, and you can actually cut the triangles or maneuver them around or whatever, so you can see if you need to go in and do what you need to do with those. Manipulate them around so you can tell if they're the same. So let's look at another set of triangles. And they're actually on 2 separate pages. So if you want to draw this one out, and then I'll see if I can get the others into it too. You have this one at the bottom, and then these 2 sets here that we're looking at. So I've tried to draw that one out along with these others. So the first thing I would do is actually do a rule out. We know that we've got to have either a side, side, side. I'm writing them right here. What else? What other type of angle theorem do we have? Angle, angle, angle. And then a side, angle, side. So you can kind of rule these out. We've got, now we're always going on what's given when we're looking at these, not on what, oh, well, maybe I know that this is going to be just like in the previous one. If I have one that's 30 and 60, then I know the last one's going to be 90, but it wasn't given to us. So here I've got an angle, and I've got a side, but that's all that's given. If I look at this one now, and this is where B looks a little interesting, because I've got this big triangle here, and inside of it I've got this other triangle. Well, let's take this other triangle out, and let's still label it. So we've got J here, we've got K, and we have L. So here we've got M and N. Now this side is 4 and this one's 3, and this is 4 and 8, then this has to be 12 along this whole side. And if this is 3 and 6, then this has to be 9 along this whole side. Now, I'm given that I've got sides here, but what theorem can I use on this one? Anybody? Anybody? Do y'all just mute yourselves and then walk away? If you give me a thumbs up if you mute yourself and walk away. Some of you have left the meeting. Okay, that's fine. So even though this angle right here is included, we could say that it's a side angle side. But let's go ahead and look at let's look at C just to make sure that this might be the one that we're looking at. So if we look at C, and the way it's done is we have a side, 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 side. Now, remember that if I'm looking at this, it may not be drawn in the same way that it should be drawn. So if I'm saying that this is the short side, then this is the short side here. So they've kind of turned this triangle a little bit. So they're saying that AB is congruent to PQ. So if we're saying that AB is the same as in proportion to PQ, then that should equal BC is in proportion to QR. So let's write these off. AB is 12 over PQ, which is 18, and that's equal to BC, which is 14, over QR, which is 20. So when I cross multiply, I know that 12 times 2 is going to be 24, and I'm going to add a 0. Is 18, what is 18 times 14? You can type it out or yell it out. I don't have my calculator right here.
252.
252. I think somebody just texted it to me. So these two are not in proportion to each other. So let's just try something different. Let's say that AB and PQ are still proportion, and let's say that AC and PR, just to double check. So AB and PQ would be 12 over 18, and that's going to equal AC over PR, which is going to be 16 over 22. So when I multiply these, what am I getting? Twelve times 22 is going to be 252? No.
264.
264. And 18 times 16?
288.
So even though this set of triangles gave you side, side, side on both of them, that doesn't mean that it's going to fit one of these theorems, because don't automatically put it down, because we did check them and they're not in proportion to each other. So this one is a little tricky because B is the only one that gave you the same angle. It didn't tell you that they were similar because it's the same exact angle. So this one is actually going to be side, angle, side, and it's going to be B. And the way we got that is because J is actually the same angle, because it's right here. But we separate them just to see. Now, you could do the proportion thing and say, okay, is 3 over 4 in proportion to 9 over 12? And 3 times 12 is 36, and 4 times 9 is 36. So yes, they are in proportion to each other. So yes, this would be the one that we're looking at, this set. Well, those are constructing things, and I don't want to construct anything right now. So look at number 5A. It says a pair of similar triangles is shown in each part. Find the measure of the segments marked with letter A, B, C, or D. So in A, we're going to find this side, and in B, we're finding this side. So how are we going to do that? So the first thing I would do is actually draw these triangles out. And this is A under number 5 on page 655. So if I draw these, and this is an angle here, we know that this is side 8 and this is 12. And then I'm going to draw this one out right beside it. And the reason I do this is just as I'm looking at them, I can actually letter them and go, okay, well, this is A, B, and C, and this is D, E, and F. And that way, when I'm looking at these sides and reporting and putting in proportions, I know that A and D are the same angle, and B and F are B and E are the same angle. So I know that AB has to be in proportion to DE, And then that means that BC has to be in proportion to EF. So now when I'm looking at these, I can say 12 over 15 is equal to 8 over A. Then we've got 12A is equal to, that's 40, and that's going to be 120. So if we divide this by 12, then we have A is equal to 10. Now, before, when I was saying, okay, if this was 2 and this was 4, I multiplied. There's nothing I can multiply 12 by a whole number, let's say, that I can multiply 12 by to get to 15. So that's why you need to know how to do the proportions. Even though this ended up being a good number and stuff, you know, an easy number, it was still that we had to write it out to figure it out. So that's part A. Now look at B. And this is where, because the angles are flipped, this is where when you draw them on a sheet of paper, you can actually unflip them and make sure that they actually look alike. Or if you can see them flipped, then keep them flipped. So you can see when I drew my two triangles here, I actually went ahead and flipped that second one. So now my triangles are in the same position, and I can see, oh, well, 6 is related to 8, B is with 12. So I can do 6 over 8 is equal to B over 12. So 6 times 12 is going to be 6 times 12 is equal to 8 times B. So 72 is equal to 8B divided by 8. And we get a 9 equals B. Now, look at this one. And I'm going to pause the recording. Okay, so for 6A, you have a triangle within a triangle. Sorry, I'm going to use my protractor now. So we have a triangle Okay, and we're told that this angle and this angle are the same. And then in the picture, we're told that this is C, this is 2, this is 15, and then this is 3. Now, when you're looking at this, you also need to know that this 15 is just this piece. This 3 is here. So this whole side is going to be 18 units long. So when you're trying to find this, you need to make sure. So we have a side angle side or whatever, because this is the same angle on both of these. So of course it's going to be the same. So we have to find these proportions. So let's say that we label this A, B, C, D, E. So we know that AB is in proportion to AC. So AB is in proportion to AC, and that is in proportion to, this is a little c, AE over AD. So this little one is in proportion to the longer one. This little one's in proportion to this longer one. Now, it gets a little bit more confusing because this has got to be added to the C. So we have A over B, which is 15 over 18, and that's going to equal C over 2 plus C. So let's see what we can do with this. Let's say that we have 15 times 2 plus C, and that's equal to 18 times C. So what you're having to do is distribute this. So we have 30 plus 15C is equal to 18C. I'm going to subtract the 15C. So now this, oh sorry, y'all can't see my work. So what I did was I got this because 15 over 18, so 15 over the 15 plus 3 is 18. The C over, now this remember is the 2 plus this C, and so that's where I got this. Now when I cross multiply, I get 15 times 2 plus C is equal to 18 times C. Now I'm having to distribute here. The 15 times 2 is 30. 15 times C is 15C. And that's equal to 18C. So I subtract 15C. And I get 30 equals 3C. So I divide by 3. And I get 10 equals C. Trying to get it so you get the whole thing on the paper, but I'm not going to be able to. Sorry, I'm left-handed and I don't realize how much I slant until I start looking up at this big screen. So is everybody okay with this? Do you have a question about what I did? Did anybody come up with the same thing? got someone typing and then not typing, so I was just waiting to see if something came through. So let's look at this one now. And see what we can get with this. So I'm actually going to, since you had an up close look, I'm just going to rewrite it for me. 6B. And we have a right angle. And then we have another line dropped here that's going to form another right angle. And they're saying this part here is D, this part here is 40, this is 25 and 20. So the same process goes here as we did a while ago, is that we're going to set this up. Now if you don't want to number them or letter them or whatever, that's fine, you don't have to, but sometimes it just makes it easier that if you just put letters around, then you know excuse me excuse me, that if you put letters around here, then it might help when you're looking at it as a whole, because we know that this 90 degrees here is the same. We know that this side is the same, this angle. And so, because this angle is the same, the 90 degree, and this angle, then this angle has to be the same. I mean, we can do a lot of geometric properties and trying to figure these out. But we're going to find out what this side D is. And doing the same thing, does anybody want to blurt in and help me out here? I'm not mentioning names because I'm wanting to, because I'm recording. I think I'm recording. Yes, I am recording. So I'm not mentioning any names, just if you want to blurt out and help me out. So because I both have a 90 degree angle here, I can say that AE is in proportion to BD. And so that means these two lines are in a scale proportion to each other. So then if I did that, then ED would be in proportion to EC. Sorry. EC, people, you got to correct me here, is in proportion to DC, because this whole thing is in proportion to this one. So EC is the whole one is in proportion to DC. AE is in proportion to BD. So we know that AE is 25, BD is 20. We know that EC is going to be 40 plus D, and then that's all going to be over DC, which is going to be 40. So as we're looking at this, 25 times 4 is 1,000, and then add a 0. 25 times 4 is 100, and then add a 0 makes 1,000, and that's going to equal 20 times 40 plus D. So 20 times 40 is going to be 800. 2 times 4 is 8, and then add your 2 zeros, plus 20 times D is 20D. So that's 1,000 equals 20D. We're going to subtract the 800 from both sides. So we have 200 equals 20D. Divide by 20. And you're left with 10 equals D. So any questions about how to do this type of problem? Is there any questions that y'all have about homework?
That test that was supposed to be today, you changed the date to the 16th. Do we still need to do it today, or do we have until the 16th to complete it?
You have until the 16th to complete it. What are y'all looking at now, me?
Yeah.
And nobody's made a comment about my new haircut.